Hi, my name is Milan, and in today's video we're going to explore Amazon SQS and Amazon SNS. These are the core messaging services that are offered by AWS, and we're going to take a look at what these services are, where you should be using them, and how to integrate them inside of a .NET application using MassTransit. Before we dive into the SQS and SNS services, I want to say a huge thank you to AWS for sponsoring this video and helping me bring AWS closer to the .NET community. And now let's discuss the high-level agenda for this video. We're going to start off by explaining what SQS and SNS are, and we will begin with SQS, which stands for Simple Queue Service. We're also going to discuss SNS, which is the Simple Notification Service, and then I'll show you how to use SQS and SNS from a .NET application using MassTransit. So let's start our discussion about the messaging services that are offered by AWS with Amazon's Simple Queue Service. As the name implies, this is a message queuing service that you can use to implement queue-based messaging between services inside of your system. Let's say I have a stock service that is responsible for making purchase orders on behalf of the users. It's going to reach out to a broker or a respective exchange and attempt to purchase a stock based on the purchase order. Now, inside of our system, we could have a reporting service that is interested in purchase order events. So we want to implement a way for the stock service to communicate purchase orders with the reporting service, and we want to do this so that we don't couple these services. And this is where a queue comes in. So we could use Amazon SQS, which allows us to manage a queue in AWS Cloud that's going to allow our two services, the stock service and reporting service, to communicate by sending messages to a queue and consuming messages from the queue. Let's say we get a purchase request on the stock service and this purchase succeeds. So the stock service is going to send a message to the stocks reporting queue, which is an Amazon SQS queue, and this is going to allow the reporting service to consume the respective messages off of this queue. So our stock service could continue producing messages, and for the reporting service to start consuming these messages, it will have to poll this queue. So Amazon SQS is a poll-based queue where the consumers have to periodically poll the queue for new messages. This is different from a push-based mechanisms that some brokers offer, where the consumers will be notified as soon as a message is published. So this is an important distinction of Amazon SQS. It is a poll-based queue, and the consumers will have to poll the queue periodically to continue consuming messages. Now, a message is typically going to be a JSON object that gets serialized into a blob and then sent over the queue. Amazon SQS offers two different types of queues. There is the standard queue and the FIFO queue. The standard queue type doesn't guarantee the order of delivery on our consumers. So we could run into a situation where we consume messages out of order. This could be problematic for some systems, and FIFO queues solve this, but the advantage of standard queues is that they have higher throughput. Now, FIFO queues, or first in, first out, guarantee exactly once delivery of messages, and they also allow us to consume messages in the order that they were produced. The downside of FIFO queues is lower throughput, and I think it's limited to around 300 transactions per second. One more concept we need to discuss when it comes to how SQS works is the visibility timeout, and this occurs when a consumer polls for a set of messages from the queue. When SQS returns a set of available messages to the consumer, it's not immediately going to delete them from the queue. Instead, it's going to start the visibility timeout for this particular set of messages, and they won't be available to other consumers inside of our system. The default timeout is 30 seconds, which is the amount of time that the consumer has to process this message and notify SQS that it's safe to now delete the message. So as our consumer, the reporting service, successfully consumes these messages, they will be deleted from the queue one by one. An obvious question is, what happens when the visibility timeout runs out? Well, in that case, SQS is going to make this message available for consumption again, which could mean that we're going to process some messages twice. And this is typical for standard SQS queues, which give us at least once message delivery. So we have a guarantee that we are going to consume each message at least once, but there could be situations where we consume a given message more than once. So it's the responsibility of the consumer to implement idempotency when consuming messages from an SQS queue. Now, let's say that we consume all of the remaining messages successfully, and now we introduce another service into our system. This is the risk management service, and it's also interested in stock purchase events. So what we could do is try to have this same service also poll the queue that we were using for communicating between the stock service and the reporting service. And this is going to introduce a problem called competing consumers, because our two services will be polling and consuming from the same queue, and only one of those services is going to win and consume a respective message. What we really want to happen is for both of these services to consume a respective message, so we would have a copy of the message delivered to the reporting service as well as the risk management service. Now, we can't do this with just one SQS queue, so a possible solution could be to create a dedicated queue for each of our downstream services. Now, imagine if our system grows and we end up with 5, 10, 15 queues that should be notified when a stock purchase occurs. And it's going to be the responsibility of the stock service to publish a respective message to each of these queues. So although we solve this problem elegantly on the consumer side, because each consumer is going to have a dedicated queue, we end up with a very big problem on the producer side, because it now has to publish to multiple queues. So is there a better way to solve this problem? Of course there is, and the answer is the Amazon SNS service. SNS stands for Simple Notification Service. What SNS allows us to do is to create a topic where we can have a producer publishing messages, and we could have multiple consumers that are all subscribed to a particular topic, and the SNS topic will take care of delivering a respective message to each of the subscribed consumers. If we revisit our previous example, where we have a purchase order incoming to the stock service, and then we want the stock service to notify our downstream services, which are in this example the reporting service and the risk management service, we can solve this elegantly using an Amazon SNS topic. So let's say we introduce a stocks topic which is managed by SNS. The stock service can now publish a message to the topic, and our two downstream services can subscribe to this topic. So when the stock service publishes a message, SNS is going to take care of delivering a copy of this message to both of our downstream services. This also makes it easy to introduce new consumers for this message. All we have to do is to add another service, have it subscribe to the specific topic, in this case the stocks topic, and when a message is published to this topic, it's also going to be delivered to the new consumer. So let's say the message is delivered to our two consumers, is going to be removed from the topic, and then we want to publish another message, and this time it gets delivered to the risk management service, but we encounter an error when delivering the message to the reporting service. This could happen because of network issues, but it could also be the case that the downstream service isn't available, and we don't have any information for how long it's going to be unavailable. So we are running the risk of losing this message for some of our downstream services if they're unavailable at the time when the message is published and delivered to the consumers. So a very common way to solve this is to introduce an SQS queue between our topic and our downstream services. So now our publisher, the stock service, is going to continue publishing messages to the topic, and then the topic will be delivering these messages to the respective queues for each of these services. Amazon SQS queues are durable, and messages are only removed from the queue when a consumer successfully processes a message. So if the reporting service is unavailable, it doesn't matter, because we will have an SQS queue that is sitting between the topic and our downstream service. When the service comes back up, it can start polling the SQS queue and processing the messages one by one. So this is how Amazon's Simple Notification Service and the Simple Queue service allow us to implement a robust and reliable messaging system. Now let's jump into the AWS console and see how we can create an SQS queue. From the AWS console, you can navigate to the Simple Queue service directly if you visited this service recently, or you can just type in SQS and it's going to show up from the search bar. So let's go to Simple Queue service. When it comes to SQS pricing, you will see that you have a generous free tier. You can make 1 million Amazon SQS requests for free each month. So depending on your usage volume, you might be able to use SQS at no additional cost. Let's go and click Create Queue to define our first queue. And you're going to be guided to this wizard where the first thing you have to choose is between a standard queue type and a FIFO queue. And as I discussed, standard queues give you at least once delivery and best effort ordering, which means that you could run into a situation where you consume some messages out of order. And then you have FIFO queues that give you first in, first out delivery, which means the order is guaranteed. And you also get exactly once processing, whereas you have at least once delivery with standard queues. FIFO queues also have lower throughput and they cost a bit more than the standard queue. So let's create our queue, and I'm going to call it our test queue. The next thing you can configure is the various configuration options for each of our queues. And I mentioned visibility timeout as one thing that we can manage for each individual queue, and the default timeout is 30 seconds. The allowed values are between 0 seconds and 12 hours. There's also the delivery delay option, the message retention period in days, and you can also configure the maximum message size, where the maximum allowed amount is 256 kilobytes. I'm going to leave all of these with their default values. The next thing that you can configure is the encryption options. Let's leave the default options here as well. Then you can configure access policies. And then this is an interesting part. You can configure which queues are allowed to use our test queue as a dead letter queue. If you turn on enabled, you can define more granular permissions for which queues can use this queue as the dead letter queue. You can choose between allow all, by queue, which allows you to select a specific queue, or you can explicitly deny all queues from using this queue as a dead letter queue. So let's click disabled. The next option would be dead letter queue, where you can designate an existing queue inside of SQS as a dead letter queue for the new queue that we are creating. And what this allows us to do is to move any messages that we cannot deliver to a consumer into a dead letter queue. This could happen because of network issues, a possible bug on the consumer so that it can't process a specific message. So there are various reasons for a message to be undeliverable, and we don't want this message to continue sitting in the queue forever. So this is why dead letter queues exist, and we can configure our undeliverable messages to be moved to a dead letter queue, where we can periodically pull from this queue and consume these messages at a later time when we fix any potential issues. If I click create queue, it's going to create our test queue, and we can start using it from our system. Now, I won't be doing this. Rather, I'm going to show you how to integrate MassTransit with SQS and SNS, because MassTransit is a very popular messaging library, and I'm going to show you how MassTransit leverages both SNS and SQS to allow us to implement messaging. So let's finally write some code, and I'm going to start from a system that contains three services: the stocks API, the reporting API, and the risk management API. And this is supposed to be similar to the example that I used in our theoretical discussion. Now, our three services are currently configured with MassTransit. They already have some consumers for the particular messages that we have in our system, and they are connected to a RabbitMQ instance that is running locally. I'm managing all of this through my Docker Compose file, where I have the stocks API service, the reporting API service, and the risk management API service. And I'm also running RabbitMQ in a Docker container in my local network. So when I start my system, my three services are able to connect to RabbitMQ and communicate using messaging. Let me also show you the setup on the two services. So let's start with the risk management API. It's also using MassTransit and connecting to the same RabbitMQ instance, and in this case it has an order-filled consumer. I'm also decorating each service with a specific instance ID that's going to allow me to differentiate between my services. So in this case I have risk management. In the stocks API I had a stocks instance ID, and then in the reporting API I have a reporting instance ID. Inside of my two downstream services, which are the reporting API and the risk management API, I have just a simple order-filled consumer that's handling an order-filled message, and it's just going to log something to the console. So nothing special going on here. In the stocks API, we have a bit more behavior. So let's explore the endpoints that we have. I'm using the AlphaVantage API for querying some stocks information, and you can connect to this API by obtaining a free API key. I also have a few endpoints, and the most important one is the post endpoint that allows me to send a purchase order request, where I can specify an order and attempt to place this order by publishing a purchase order sent message. Then I'm going to consume this message from the same service. So this is a sort of a listen to yourself pattern. So we consume the purchase order sent message, where we check for this order and obtain the latest stock price using the third-party API. If the last price that we get from the API is less than the limit price on the order, then we're going to fill this order, set a respective price, and publish an order filled message. The other two services that we have are both listening for this message. So let's go ahead and start the application that's currently using RabbitMQ so I can show you how all of this works locally. My application is running in the background using Docker Compose, and here are the three services that we have: the stocks API, reporting API, and risk management API. And we also have a RabbitMQ instance running inside of the same Docker network. Now, if I open up the RabbitMQ management UI, which is also available locally, we can take a look at the exchanges and queues that are configured by MassTransit. So MassTransit can connect to your broker and create the required exchanges and queues in the case of RabbitMQ. So you can see we have an exchange for each of the messages that we have in our system, the purchase order sent message and the order filled message. But we also have some exchanges for the consumer. So we have an order filled exchange for the reporting service and the risk management service, as well as a purchase order sent exchange for the stock service. Now let's take a look at the order filled exchange. In the bindings, you can see that we have the order filled reporting exchange and the order filled risk management exchange. And these exchanges are bound to the respective queues. So you can see the order filled risk management exchange is going to deliver messages to the order filled risk management queue. And this is how RabbitMQ allows us to implement fan-out messaging. We have fan-out exchanges that can deliver messages to multiple queues. If I open up the Swagger UI and try to make a stock purchase, let's say we want to purchase a share of Amazon stock. I'm going to set the limit price of $185, and let's say I want to purchase just one share. If I send this request, it's going to quickly succeed and is going to publish a purchase order sent message. Now we're going to handle this message by consuming it with a MassTransit consumer, and when we obtain the last price for the Amazon stock from the API, we can figure out if we can fill this order. So the order is filled, and now we're going to publish the order filled message. And now I'm going to hit the breakpoint in the two consumers that I have. So here is the order filled consumer. In the reporting service, I'm going to hit continue, and then we land on the same breakpoint in the order filled consumer, but this time in the risk management service. So this is how we can easily implement communication between our services using messaging. Now I'm going to stop our application, and let's go back to the program file of the stocks API, for example, and let's see what we can do to replace this connection to RabbitMQ with SQS. So all you have to do is to install the respective NuGet package and configure some parameters. So let's look for MassTransit SQS, and I'm going to install the MassTransit Amazon SQS NuGet package, and of course we're going to install the latest version. Now I'm going to add this NuGet package to the other two projects that we have by just updating the project files directly rather than installing it through the NuGet UI. And let's see what we have to change here to start working with SQS. So instead of using RabbitMQ, you will say using Amazon SQS. Instead of specifying a URI to the host, I'm going to specify the region that I will be using for my SQS and SNS instances, which is going to be EU Central 1. And then instead of the username and password, I need to specify an access key and a secret key. Now I'm going to fetch these values from my application secrets. So let's look for the access key under Amazon SQS and the secret key under Amazon SQS as well. I'm going to show you how to get these values, as well as setting up an IAM user and the respective policy, or an alternative could be that your machine is authenticated with AWS, and in that case you don't have to provide an access key and a secret key. But I'm going to assume that your machine isn't authenticated with AWS, and I'll show you how to set this up step by step. Now a few more things that I want to configure here is to set a scope for the respective topics in SNS, and this is just going to be a prefix that's going to be added to all of the SNS topics that MassTransit is going to create. So I'm going to say scope and then specify stocks, or rather let's specify stocks platform, and I'm going to specify true as the second argument. And this will allow us to differentiate the topics for this particular system from all of the other topics that we have in SNS. When it comes to your endpoints, which are essentially going to be your queues, you can provide another argument to the configure endpoints method and specify the kebab case endpoint name formatter, which is what we were already using, and you can also specify a prefix that's going to be applied to the queues. So let's specify stocks platform, and I'm going to specify false for include namespaces. And now I have to replicate this in the other two services that I have. So let's go and update the risk management API, and let's comment this out. And then let's update the reporting API by pasting over the same code, and I'm going to comment this out. Now, a very important thing that you might overlook, and it allows our services to communicate with each other, is having a dedicated assembly where our message contracts are going to live. In this case, I have a stocks platform contracts project, and this is where my order filled message and the purchase order sent message lives, and all of my free services are going to reference this project so that they can see these same messages. Now, what's really important here is that your messages live in the same namespace, and they have the same structure. So if I had a copy of the purchase order sent record in this exact namespace in all of my free services, then everything would be fine. But it's much easier to define one contracts project so that you can share your messages between services. Later, you can distribute this using a NuGet package if you want to extract these services into separate repositories for a microservices environment. Okay, now it's time to obtain an access key and a secret key so that we can connect our application to SQS and SNS. So let's jump into the AWS console. From the AWS console, I'm going to look for IAM, which is Identity and Access Management. And the first thing I want to do here is to define a new policy. I'm going to click Create Policy, and I'm going to look for the JSON policy editor. And now I'm going to paste in our ready-made policies that I have, and you can find this in the MassTransit documentation for SQS, and essentially this is going to configure the required level of access that MassTransit needs to interact with SQS and SNS. For example, for SQS, it needs to be able to receive messages, create queues, delete messages, send messages, and so on, and you will have to allow access in any region and any queue. Now for SNS, MassTransit needs to be able to create a topic, publish a message, subscribe to a topic, and it also needs to be able to list topics. So let's go ahead and create this policy. I'm going to click Next. Let's give our policy a name. I'm going to call this MassTransit SNS SQS Access. And now I'm going to click Create Policy, and my new policy is ready. Now I'm going to head over into Users, and I'm going to create a dedicated user for interacting with MassTransit. So let's just call this the MassTransit user. For the permission options, I'm going to click Attach Policies directly. And then let's look for our custom MassTransit policy that we just created. So I'm going to assign this policy to my new user, and let's go ahead and create this user. So now that we have our user, we can go into the user instance, go to the Security Credentials tab, and create a new access key. So I'm going to create a new access key. I'm going to click Next. Let's give our access key some value. You can give this access key a description so that you know why you created it. I'm going to leave this empty. And finally, when you click Create Access Key, you will get an access key value as well as a secret key value. Now I'll go back to my application and specify these values in my user secrets. So back in Visual Studio, let's go to Manage User Secrets under the Stocks API, for example. And I'm going to add a key value for Amazon SQS access key. And here I'm going to paste the value that is exposed through the AWS console. And I'll also do the same for the secret key value that you can also copy once you create an access key. I will need to specify these values for the remaining two services that I have so that they can all connect to SQS and SNS. So with the access key and the secret key specified in my user secrets, and these are sensitive values that you don't want to expose in your application settings because they can easily find their way into source control, and this is something that you want to avoid. We specify the access key and the secret key values inside of our user secrets so that we can avoid specifying them in the application settings, because that's how they can easily find their way into source control, and that's something you want to avoid at all costs. You can also provide these values through some sort of secrets manager. Now at this point, we are ready to start the application and start using SQS for sending our messages with MassTransit. So let's start the application. And then from the Swagger UI, let's see if we are able to purchase a stock. I'm going to try to purchase another share of Amazon stock. Let's go ahead and send this request, and you will see that I land on a breakpoint inside of the purchase order send consumer. So we are definitely able to send and receive messages. Let's see what happens if I click continue. We're going to land in the order filled consumer, and if I hit continue again, we will land in the order filled consumer in the risk management service. So now I want to jump into the AWS console and show you what happens inside of SQS and SNS. If we open up the Amazon SQS service, you will be able to see that MassTransit has created 3 queues for us. We have the order filled reporting queue, the order filled risk management queue, and the purchase order sent queue for the stocks API. So our queues are all in place. They are standard queues and not FIFO queues, although this is something that you can configure manually if you don't want MassTransit to manage your broker topology. Now let's jump into one of these queues. For example, the order filled queue for the risk management service. You can see that we have a respective SNS subscription, and we're going to take a look at the topics in just a moment. You can also see if you have some Lambda triggers, because a typical way to use Amazon SQS is to connect it to a Lambda function that's going to trigger whenever a message lands on the queue. You can also take a look at the dead letter queue if you have one configured, and in the monitoring tab, you can observe what is going on with your SQS instance. In this case, you can see that we have received and sent one message. So that's our queues. Now let's open up the SNS service, Amazon, which is our simple notification service, and I'm going to navigate under topics. And here you will see that we have two topics. We have the stocks platform contracts order filled topic and the stocks platform contracts purchase orders sent topic. The first part here, stocks platform, is the prefix that we assigned to all of our topics using MassTransit. Then the next part is the actual namespace where our message contracts live, which is the one project that is shared between our three services, and then we have the actual name of the message. So we have an order filled topic for the respective message and a purchase order sent topic for the respective message. Now let's go into the order filled topic. And here you can see that MassTransit configured two subscriptions on this topic, which are going to connect the two respective queues for the order filled message to this topic. And this is how we are able to publish an order filled message. It's going to be delivered to this specific topic, and then the topic will take care of delivering that message to the respective queues. Another interesting thing here is the delivery policy that is configured for this topic, where you can see what is the default retry policy. And this is how we can use SNS topics and SQS queues to implement a robust messaging system. If you want to clean up your resources, you will have to go into the SNS topics and delete them one by one. You will have to do the same for the subscriptions as well as the queues that you have inside of the SQS service. What I want to highlight once again is how MassTransit makes it so easy to switch message transports. We started with a RabbitMQ broker and we switched to using SQS and SNS, and all we had to do was install a new NuGet package, configure the SQS transport, and tell MassTransit how to connect to AWS by specifying an access key and a secret key value. I hope you got value from this video. Let me know in the comments which AWS service I should cover in one of my future videos. If you want a gentle introduction to MassTransit, then I suggest that you watch this video next. Check out my courses to improve your software architecture skills, and until next time, stay awesome.